Now in this topic, that is the force, Newton's laws of motion. First of all, we should know what is the force. As you studied already in class 9, that the force is that external cause in the form of a push or pull which can change the shape, size, direction and the state of motion of a body. That is, if a body is in motion, it may bring the body in rest, and if the body is in rest, it can bring the body in motion. That is, it can change the motion. You know why the body moves? It is only due to the unbalanced force. Okay, so unbalanced force is the main cause to change the state of a motion. So to know much more about the force, first we will discuss also the very important property, that is the inertia. Inertia, actually it is the inherent property. Inherent property means it is the inbuilt property of a body. Means every body has a tendency to remain in the same state. That is, if it is in motion, it will be continue in motion. If a body is in rest, it will be continue in the rest. So to change the state, you have to apply the force. So according to this, we can write the definition of the inertia, and which is also known as the law of inertia, which was given by the Galileo. According to that, if a body is in motion, this is the property, inherent property of the body, by virtue of which a body remains in the same state of motion. That is, if it is in motion, it will be continue in motion. If it is in rest, it will be continue in rest. So inertia is of two types, that is, which is known as the inertia of rest. Second is the inertia of motion. And one more type of inertia is given in some books. You should also know it. That is the third type, which is known as the inertia of direction. Inertia of direction. Okay, so it is very much clear from these headings. Inertia of rest, that is, if a body is in rest, it will be continue in rest unless an external force applied on it. Inertia of motion, that is, a body is in motion, it will be continue in motion unless an external force applied on it. Inertia of direction, a body will remain in the same direction of the motion unless an external force applied on it. So these are the three types of the inertia which you will study in your syllabus. Okay, so many examples we can discuss already, because you know already studied in class 9, so I'm not going in deep about the examples, practical examples of these three types of the inertia. We are moving to the, and one more thing, very important, how can we measure the inertia? Okay, you should know, because the next chapter, that is about the rotation of the motion, rotation of motion, you will need this knowledge. That is the measurement of inertia, how much it is, how it is possible. You should know it is only and only by the mass of the body. Okay, mass is the only measurement of the inertia. More mass, more inertia. Means if a body is heavier, then it means you have to apply greater force. If a body is lighter, then you have to apply the force to change its state very less. So mass is the only and only measurement of the inertia. You should know it. So when the body moves due to the force, obviously it comes into motion, and if also body has some mass, then the mass, the product of the mass and the motion, that is the velocity, is termed as a new physical quantity which is called the linear momentum. So see, what is the linear momentum? Linear means along a line. Linear momentum denoted by the P. It is the product of mass and the velocity. Linear momentum is the product of mass and the velocity of the body. Remember, linear momentum is a vector quantity, so its direction is always in the direction of motion of the body. So remember this formula, very useful in next coming chapters. So remember it. And from here you can find some relations. Suppose the momentums are same of two bodies. In that case, P1 is equal to PT if you write. So M2 V2. So in that case, what will happen? V1 upon V2 is equal to M2 upon M1. That is the inversely proportional. Means for the greater mass, velocity will be less. For the less mass, velocity will be greater. So it is the inversely proportional, you can say. So we can find the different relation using this concept, that is the P is equal to mv. Now on the basis of the inertia, we can state the Newton's first law of motion. So students, Newton's first law, because Newton has given 3 laws. Okay, very basic laws of the Newtonian physics. Okay, Newton's first law of motion. Okay, actually it is also known as the Galileo's law of inertia also. Galileo's law of inertia also. Okay, same thing. So Newton's first law of motion, that is, if a body is in rest, it will be continue in rest. If a body is in motion, it will be continue in motion. Okay, unless an external force applied on it. Okay, it means force is required to change the state. It means if a body is in motion, it will be continue in motion, and if it is in rest, it will be continue in rest, unless an external force applied on it. So this is the first law of motion. There are so many examples of the first law. There is suppose a body, you can say, suppose you are sitting in a bus and the bus starts suddenly, then you will be pushed backward direction. Okay, and suppose the running bus stops suddenly, then you will push in forward direction. Okay, why it is so? Just I am giving as an example because already studied in class 9th. Suppose you are sitting in a running bus, then when the bus stops suddenly, then your lower portion of body, which is in contact with the surface of the bus, will stop suddenly, but your upper part of the body will be continuing the journey, and that's why you will feel that you are pushing in forward direction. So unless and it means, you can say first law means to change the state of motion, force is required. It means if there is no force, body will continue in the same state of motion. So this condition you can acquire by the two ways. First way, you can say if the forces are balanced. Okay, that is the F is equal to 0. In what conditions it is possible? 2 conditions are possible. You can say V is equal to 0. That is, body is in rest. So acceleration, it means the acceleration will be 0. If acceleration is 0, it means the F is equal to ma is equal to 0 in this case. So no force. It means if a body is in rest, the body will remain in the same state of motion because the force will be 0. Okay. Second case, you can understand. Suppose change in velocity will be 0. change zero, it means again acceleration will be zero, because body will remain in the same state. That is, if there is no change in the motion, it means you can say that is there is no variation in the velocity. So acceleration means the change in the velocity per unit time. So acceleration will be zero in that case. So here we can say v is not equal to zero. Okay, but the change but that is the body is in motion. Body is in motion, but the change in velocity is not zero. So is zero. So that's why the acceleration will be zero, and again f is equal to zero in this case. So if the initial velocity is zero, you can say zero, then body will remain, that is in rest, body is not moving, so no force is acting on it, because the body, if body comes into motion, it means there is some force. So force will be zero in this case, and in this case also force will be zero. So I think it is clear what is the Newton's first law of motion states. That is, to change the state of motion, force is required. Force is required. Without force, body will not come in motion or not will change its state of motion. That is, if a body is in rest, it will be continue in rest. If a body is in motion, it will be continue in motion. Thank you, friends. In next video, we'll discuss about the Newton's second law of motion. Thank you.